All right, so people asked about problem 7 as well. And again, this is actually something that you can get out of the formula sheet. I think that on this one, I will just go from first principles, but there is a nice formula. Let's see if I can find it. Here we go. This right here is all you really need. These formulas talk about the sum and the product of roots of a polynomial equation. And so if you want to just use the formula, you can, but I actually think it's pretty slick here to just do it from first principles. And so basically what I know is that if I have a root, then that tells me the factor. So if I have x equals 2 is a root, then I know that x minus 2 is a factor. And so we just have here 3 roots, alpha, beta, alpha plus beta. I'm just going to write a and b because it's easier for my handwriting. So if I know alpha is a root, I'm going to write x minus a. If I know beta is a root, I'm going to write x minus b. And if I know alpha plus beta is a root, I'm going to write x minus a plus b. And I know that this is the original cubic equation. I know it's the original cubic equation because the leading coefficient is 1. And so x times x times x gives me x cubed. And I'm just going to copy down the minus kx squared plus 3k. So what I can do is just expand out the right side, and then my coefficients need to be equal. And so on the right side, I'm going to have x times x times x. That makes x cubed. And then let's think about how I can get x squared. How can I get x squared? Well, I could get x squared if I did x times alpha plus beta, or if I did x times b times x, or if I did negative a times x. And so if I factor those out, I have a negative b, and a negative a plus b. That's the coefficient of x squared. And then similarly, the coefficient of x in this problem is it's really irrelevant because we don't have an x coefficient on the left side of it. And so what we really care about, I'm just going to put a little ... because I don't care about that. And then the coefficient of the constant happens to be negative a, negative b, negative a plus b. Because the only way you get a constant is if you multiply all of them. Sorry, the negative's on the outside of the parentheses, not on the inside of the parentheses. Okay, this piece right here is my x squared coefficient, so that has to equal negative k. And this piece right here is my constant, so that has to equal 3k. And so the problem really turns into a system of equations. So let's start by writing out our two systems. I'll write one in purple. So we know that negative k equals negative a minus b minus a plus b. If you distribute your negative, then you'll see that negative k equals negative 2a minus 2b. And we can make it positive, so k equals 2a plus 2b. Okay? Then let's use blue for our other system of equations with the constant. And the constant tells us that we have 3k is equal to negative a times negative b times negative a plus b. Great. One trick I'm going to do here is because I see a plus b, is I'm going to go back over to my purple problem and divide everything by 2 to get k divided by 2 equals a plus b. I'm going to substitute that into my blue problem. So I have 3k equals a times b. I'm just going to cancel the two negatives to make a positive, times negative k over 2. That's great. There was one other thing in the problem, original problem, that I haven't talked about yet, which is that a times b is negative k squared over 4. Let's put that into our blue equation now. 3k equals, what was a times b is negative k squared over 4. So we have negative k squared over 4 times negative k over 2. That's great. So we have multiply both sides by 8 to get rid of the fractions. So that would be 24 k equals k to the third power. You can divide both sides by k because k is greater than 0. And so then you get uh, 24 equals k squared. And then you take the square root. And that should be good there. Unless I made some little numerical error, that's the process here. And if you want to look back at the formulas, you'll notice that on the formula sheet, the purple problem is this right here. The sum is the opposite of the second coefficient, and it was a minus k there, and so that's what we have here. And that the blue equation is this second one, that the product is equal to the constant. So there you go. That was problem 7.